Howdy everybody in YouTube land. This should be the third and final installment of the video series on this monitor. This video is probably going to take some editing over the course of the next couple weeks because there's still parts that has to be ordered and times to have to be able to fit in and bouncing it between jobs and work and blah 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 blah, on and on it goes, you know what I mean. So the last video was pretty much me just rambling on about what could be the problem, but never actually finding the problem, okay? The monitor here, I spent the course of the last week trying to remember, like, you know, come on here. But before that, I didn't get on video, but I concluded that the second board is bad. The one that was in the box, which I had a feeling it was. And actually, this is the part that's bad. See that hole burnt in the transformer? Yeah, there's the problem. This thing was throwing an arc from that hole all the way up to the metal shield. As soon as you turn it on, it was just a continuous arc. So it's junk. I might be able to cut that transformer open and figure out what failed, you know, get some high voltage silicone and seal it or whatever, but it's not worth my trouble, you know. So I figured, okay, well, what if I just take this flyback and just move it over here? And I'm thinking, well, I could probably do that. It's sort of cheating, but the problem is, what if this thing is actually eating the flyback transformers? I'll destroy another perfectly good flyback, and then I'm screwed. This monitor goes into the garbage can because these flybacks are impossible to find. That's the number of the flyback. It cross-references to a couple different HR flyback numbers, but I can't find either one. There's a website that shows in Europe somewhere, and they're like $50. Well, I can buy a whole nother one of these working for $50. So it's not worth it at that point. Anyway, so I got to thinking, I'm like, you know what? Let me review my first video I made on this, because I remember this thing had vertical distortion, so I was automatically assuming this chip, maybe a cap or the output or something like that. But then I noticed the horizontal output failed. You'll see these, but I'll get to those in a minute. The horizontal output failed, you know, so I'm thinking, well, there's got to be something. There's got to be something. So I watched my previous video, and I noticed not only did it have vertical distortion, but it also had horizontal pin cushion distortion, and it was wavy, like filtering problems. So that automatically set up a red flag. We've got bad capacitors somewhere. So I'm thinking, you know, but then I get a closer look. I'm looking down here, and I'm seeing all of this. This crap is normal. I don't know if this is just chemicals from the board manufacturing, but I've noticed some alligatoring down here, dirty copper, and I've worked on enough logic boards to know that that's capacitor leakage. At least that's what it looks like. So then I'm like, you know what? Let's look over here. Well, you can see it down in there too. So I'm thinking, okay, if that's not a bad capacitor, I'll eat my own hat. So that tells me right there that it's bad capacitor. Okay, so then we flip it over. Bingo. You can kind of see, yep, see the wet spot, the goo, and all that, and that's this guy right here. Yeah, she's done, and it smells. And I knew as soon as I seen that, I seen the alligatoring and the damage to the board. The closest capacitor was right here, and there's one over here. And as soon as I heated the pin, it started sizzling, and it smelled like that, you know, distinctive dead fish electrolyte smell. So I knew that's the problem. That's exactly the problem. So we know for a fact that's what it is. Now, basically, we have two resistors here, which I pulled out, and notice how hot they get. And I mentioned that in the previous video. These resistors couple the drive current from the horizontal drive transformer all the way to the base of the output transistor. Okay? So, but how in the world was it distorting the vertical as well? Well, if you take a look, this transformer here is part of the pin cushion circuitry. It's a passive pin cushion adjustment circuit. So there's no adjustment for it, which is why they have these little magnets here, and this is to set exact purity and magnets and all that stuff, because there's no real way to adjust the pin cushion. Now we have that out of the way. The pin cushion circuit is coupled through the horizontal yoke as well as the vertical yoke through this capacitor. And there's some other ones here that are bad too. You can kind of see where they're leaking a little bit, but this was the massive leaker, which makes sense because these high, power wasting oven factories right here are dissipating right into that capacitor. So guess what's going to happen? It's going to leak and dry out. It's old enough to do that anyway, but that's only going to exacerbate the problem. And I pulled this one out. It's also leaking, and this is a filter cap for the horizontal drive. So yeah, that can cause the horizontal distortions, and this is going to cause the vertical and pin cushion distortions. All those are suspect. So there's your problem. Now, I mean, who does that? Anytime you're going to put a capacitor right next to a heatsink, what's going to happen? It's going to dry out and fail. So what brilliant engineer in the right frame of mind is just going to, I mean, look at that. Who does that? Who puts this right next to, drives me nuts. I mean, look over here. Another one. This heatsink is carrying the load of the horizontal output and the vertical output. And what do they put right next to that? The B plus filter to the vertical output right next to the heatsink. That is an awesome spot for that. Grr. I hate people. People suck. So anyway, yeah, this one was leaking a little bit. So here's what we're going to have to do. We're going to have to clean this board up for sure. And then I'm going to take a tally. If one cap's going to go bad, the rest of them are. So I'm just going to go ahead and take a tally and get a bill of materials together and just start replacing them with new ones. So, I mean, they're old enough now. It's got to be done. So it is what it is. I will come back to this video once I get the parts ordered and in here, and then we'll install them and see what the hell happens. Oh, yeah, and another thing too is you could tell the cap goo is leaking for a while because look at this jumper link. I mean, it's just corroded all to high heaven. I mean, ugh, it's bad. Ugh. Garbage. It's got to be replaced, fixed, cleaned, and everything else along with it. I took these two main filters out, and yeah, look at that one. Yeah. And that's this guy right here. Crusty, especially on the negative lead. That's where it starts. So it always starts on the negative lead. These two go right here. And again, negative lead, crusty. This one's not actually leaking so bad or at all yet. That's the 82 microfarad 160 volt. This is 2235. This is in the vertical circuit, by the way. This is a B plus filter that goes right into the flyback, but this is in the vertical circuit on the yoke return. So yeah, it's done. It's done. And there's these resistors that go in here, and these leads are kind of crusty too. These resistors are probably good, but I'm just going to go ahead and replace them just out of the sake of knowing that they were involved in this fiasco. So, and it's a common problem too, because look, this board here is the same deal. I mean, look at those resistors. That capacitor is probably, if not leaking, it's starting to. And actually, this board don't look bad, but I would never trust a used capacitor. I mean, it's a 2200 at 6.3. That is a common. They still use those today in LCD power supplies. I mean, come on. They're cheap enough. Just replace the damn thing. So that's what we're going to do. I'm going to change all these capacitors out. I'm going to get a tally, get it all ordered, probably from Mauser or DigiKey, one of those places like that. Chooch it. Get it running. So I'll be right back after a week or two.